Let's begin. Today is December 1st, 2024, and we're solving the Daily Turing Machine Puzzle. Today's puzzle uses the following 6 criteria cards. Criteria cards 2, 5, 12, 19, 20, and 22. And the puzzle uses the orange verification cards. The code above is your way to get more information on today's puzzle by searching the code on turingmachine.info. Let's go solve. So in the grid above, we've got our 6 criteria cards. On the top row, we've got criteria card A, criteria card B, and criteria card C. On the bottom row, we've got criteria card D, criteria card E, and finally criteria card F. So criteria card A takes a look at our first digit, that triangle digit, and we'll be comparing it to the number 3. So should the value of triangle be less than 3? Should it be equal to 3? Or should the value of triangle be greater than 3? Criteria card B again takes a look at our first digit, and the Turing Machine will let us know whether its value is an even digit or an odd digit. Criteria card C will take a look at our first and last digits, triangle and circle, and compare them. So should the value of triangle be less than circle? Should they be equal? Or should the value of triangle be greater than circle? Criteria card D will take a look at our first and middle digits, triangle and square, add them up, and compare the sum to the number 6. So should the sum be less than 6? Should the sum be equal to 6? Or should the sum be greater than 6? Criteria card E will take a look at our 3-digit solution, but this time it'll let us know a little bit about its structure, so to speak. And there are 3 cases. One where the 3-digit solution has no repetitions, as in the example 125, or the Turing Machine could inform us that it's a double number, as in the example 112, or it could even tell us that it might be a triple number, as in the example 222. And finally, criteria card F again takes a look at our 3-digit solution from triangle to square to circle, but this time it'll let us know a little bit about the ordering of the 3 digits. Should the digits appear in an ascending order, meaning that they're increasing, as in the example 135? Or could the 3-digit solution appear in a descending order, basically decreasing, as in the example 421? Or finally, it could be that the 3-digit solution has no order. Let's take a look at the example of 231. Notice that it goes from 2 to 3, it increases, but then it goes from 3 to 1, then decreasing. Of course, you could also have a code that is decreasing and then increasing, but it basically is that shift from one to the other. That is one way to define a 3-digit code as having no order. Now, we've seen in previous puzzles that if ever you have consecutive equal digits, that can also represent a 3-digit code as having no order. So let's take a look at this example of 112. The ones are consecutive. And so the reason I bring that up is that when it goes from 1 to 1, that change, there is no change. It doesn't increase nor decrease. And ascending and descending do strictly mean that they will be increasing or decreasing. Since 112 has no change from 1 to 1, that's why I say that consecutive equal digits have no order. And remember, the objective of today's puzzle is to find that unique 3-digit code that abides by the 6 criteria cards we just described. And we're going to start off with an initial proposal of 314. So the first thing I think I'd like to test is criteria card B. Okay, so the Turing Machine does not approve of my choice in triangle. Notice I did pick an odd 3. So the Turing Machine is letting us know that triangle should actually be an even digit. So let's go ahead and type that up in our notes in section B. And we'll say that triangle is an even digit. And of course, since it is even, let's go ahead and cross out the 3 odds. And the next thing I think I'd like to test is criteria card D. Okay, so the Turing Machine does not approve of my proposal. Notice that criteria card D is adding up the first two digits. So 3 plus 1 is 4. 4 is less than 6, but the Turing Machine does not approve of that. So it must be one of the other two cases. So either the sum of the first two should be equal to 6 or be greater than 6. So let's go ahead and type that up in our notes in section D. And again, we'll say that triangle plus square should be either equal to or be greater than 6. Now, I don't think we can cross out, or can we? Hold on. Yeah, I think we can cross out, I believe, square 1. Because if you add 1 even to a 4, that sum is still less than 6. So we can cross that out. I don't think we can cross out the 2 in triangle, since you could always add it to 4 or 5. And likewise can't cross out the 2 in square, because you could add it to a triangle value of 4. So obviously, yeah, we can anticipate that the sum is either going to be equal to or greater than 6. And I think the next thing I'd like to test is criteria card C. Okay, so the Turing Machine does approve of my choices in triangle and circle, our first and last digits. So notice that my triangle value of 3 is less than my circle value of 4. So yes, it is true that triangle should be less than circle. So let's go ahead and type that up in C. And that is that triangle, triangle should be less than circle. And let's see, can we cross out any values? Well, if triangle is to be smaller than circle, it seems that circle cannot be a 1. Because if circle were 1, there's nothing smaller for triangle to be. And let's see, anything else? At this point, well, I think you can even cross out 2. Well, let's see. There is no, well, I guess there is a possibility of having a double number. Let's see. Yeah, you could have a double number. But let's do this. Even though criteria card E and F, we've seen in other puzzles where it's not quite the same as criteria card E, but the other one that's very similar. I think it kind of groups the double number and the triple number together in a, is that right? Oh no, I think it's more the no repetition and the triple number that they group together as no pairs, and then you have a pair. But sometimes they do play off of each other, E and F. And let's see if we can deduce some of these. I think the argument's been where if you look at criteria card F and you say, well, let's suppose that maybe the solution might be an ascending solution. Well, as I stated at the top of the video, we did state that ascending and descending alike, they are strictly increasing. So that would mean that there would be no repetitions. So I think for that reason, if you were, again, to presume it's ascending, it would make criteria card E irrelevant, because if it was ascending, you would know for a fact, by definition of what ascending means, that there should be no repetitions, making criteria card E irrelevant. Of course, same thing for descending. They're strictly decreasing. no repetitions. So I think we can safely deduce that criteria card F, the solution should have no order. So let's go ahead and type that up. We're going to deduce that the solution has no order. And let's see if we can make the same sort of argument, but in reverse. If we knew a triple number, if we knew that the solution were a triple number, that would be a solution that has no order. And that's because, as I mentioned again at the top of the video, when you have consecutive equal digits, whether 2 or 3, there is no change. So that means that a single digit repeated 3 times would have no order. And that would, again, make this criteria card F irrelevant. And if you had a double number, whether consecutive, as in 1, 1, 2, or otherwise, 2 pairs of numbers separated by that middle square digit, those would also exhibit no order. So I think it's safe to say that we can then also deduce that there are no repetitions. So let's go ahead and type that up, and we'll say we're going to deduce that the solution has no repetitions. Okay, and so since there are no repetitions, that means that they are unique. So I think my argument was, going back to criteria card C, triangle has to be smaller than circle. Well, if circle is 2, there's nothing smaller that triangle could be, because you can't have duplicates. So let's go ahead and cross out the 2 in circle as well. And so yes, now if circle were 3, there is a viable candidate for triangle to be. And the same goes for all of the circle values. So yeah, I think that might be it. We didn't cross out anything in triangle. So yeah, there's nothing to update criteria card D with. Okay, well, that does it for this round. We did complete our 3 Turing tests. We're now going into the phase where we'll be discussing how to construct a good second round proposal. So notice we did not test criteria card A, comparing our first digit to the number 3. Obviously, now that we know that it's even, of course, it can't be equal to 3. It's going to be less than or greater than. And criteria card D is a bit outstanding in that we don't know if it should be equal to 6 or be greater than 6. And we were able to deduce criteria cards E and F. So we technically don't have to test those 2 criteria cards. So it seems like it just comes down to A and C, and let's see if we can maybe deduce the second part in D. Can we eliminate one or the other? Well, let's take the case of perhaps maybe the sum of triangle and square are equal to 6. So we would be dealing with, 2, 4 or 4, 2 in some combination. And of course, that would mean that we would have to figure out what circle might be. Well, it seems to me that if the easiest case would be where triangle is 4, making square 2, and then forcing circle to be a 5, because we do want to make sure that circle is larger than triangle. And so that would force our choice of circle to be 5. So 4, 2, 5 seems to be the easiest candidate. And then what about if it were 2 and 4? Triangle 2, square 4. Okay, so that sum is 6. But then you would have to now pick between 3 and 5 for circle. So is there anything here? Well, of course it couldn't be a 4 because of the duplicates. But what about 3 and 5? That just doesn't seem... Oh, okay, yeah. So that would mean that it would be 2, 4, 3 because 2, 4, 5 would be increasing. So we would be down to 2, 4, 3 or 4, 2, 5 if the sum were 6. Okay, what if it weren't? Is there anything that we could do? Let's see, if the sum were greater and if it were 2, that'd be 2, 5. And then we would be stuck, I think, 2, 5 between 3 and 4. And both of those are greater than the 2 in triangle. And they would both have no order. So I think those would be ambiguous solutions. There's no way to distinguish those. So I don't think that sum of greater than 6 is viable. What about 4? Well, if triangle were 4, that would force circle to be 5. And then if it's greater, 4, 5, well, then that would be 4, 2. Oh, no, sorry, 4, 3, 5 would be that possibility because you want it to be greater, no duplicates. So yeah, 4, 3, 5. So there's a little bit of everything. That's interesting. That said, the way these puzzles and these criteria cards work is that, they're supposed to somehow differentiate the solution somehow. And it seemed that the sum of 6 was a more plausible variation. So again, that was 2, 4, 3 or 4, 2, 5. And so let's see. Can we... Yeah, let's go ahead and choose one of the sum of 6. And so again, 4, 2, 5. So I think the best alternative would be something like 2, 5. I'm sorry, 2, 4, 3. Would that be correct? 2, 4, 3. Yeah, let's go with 2, 4, 3 and see where that takes us. So just really quick, that first digit is even, yes. The first is less than the last, yes. We are determining, well, I'm picking a solution where the sum is equal to 6, and there are no repetitions and no order. So yeah, everything seems to work out. Okay, so let's go ahead and test criteria card A. Okay, so my choice in triangle 2 is less than 3, and the Turing Machine approves of that. So let's go ahead and type that up, and we'll say that triangle should be less than 3. And so let's go ahead and cross out the 4 in triangle. So we do have a 2. Now, of course, 2 is smaller than all the digits below in circle. Okay, so we couldn't do any improvement there. But that said, we can cross out square 2 because of no duplication, and 3 because 2 plus 3 is less than 6. So we can eliminate it. So we're down to either 2, 4, 3 or 2, 5, 4. And I believe, or actually, hold on, 2, 4, 2, 4, 3, 2, 5. Actually, I think now we can deduce that it has to be 6, because if you choose greater than, that forces you to pick 5. So it is 2, 5. That would be greater. But then again, how would you pick between 3 and 4? There's no duplication there with the 2 and the 5. So they're still viable. 3 and 4 are still less than 2. And what else? They all would have no order. And no duplication. So it seems like we can deduce that the sum cannot be greater than 6, because 2, 5, whether 3 or 4, those would be ambiguous. I don't see how you could distinguish between them. So so let's go ahead and cross out the greater than, and we're going to say here that we deduce that result based on what available numbers there are. And so I'm going to say that the solution should be 2, 4. So let's cross out the 5 in square. And then because of duplication and no order, we can eliminate the 4 and 5. So it looks like our solution should be 2, 4, 3. So let's go ahead and type that up. 2, 4, 3. And let's quickly review. So is the first digit smaller than 3? Yes, it is even. The first digit is smaller than the last. That's correct. And the sum of the first two is 6. We deduce that based on the numbers. And we outright deduce the last two criteria cards, E and F. So no repetitions, and they have no order. That looks to be true. It increases and it decreases. Okay, well, let's go verify 2, 4, 3 as our solution. 2, 4, 3. Fantastic. Well, how did we do versus a Turing machine? Well, I think we did pretty well. It is a 6 criteria card puzzle, and we only did it in using 4 tests, obviously aided by being able to deduce E and F. So we did B, C, D in the first round, and then A in the second round, and C and A were the only correct ones. So let's go ahead and type that up. So B was incorrect, C was correct, D was incorrect, and then we just tested A to be correct. And we beat the Turing machine by 2 questions. Well, no doubt these deductions really helped out in limiting the number of tests that we had to do. So such a fantastic opportunity. And, I've just started to kind of commit those 2 to memory. So even though I kind of recognized it at the beginning, I just left it to when I really needed it most. Well, how about you? Are you picking up on some of these deductions that I've kind of outlined in some of these videos? And has that helped out? Or also, how did you solve? What criteria cards did you use? And what interesting facts can you share? Did you have an aha moment? Please add those thoughts to the comments. Well, if you liked the video, please do give it a thumbs up so that more people can find the channel. And of course, don't forget to hit subscribe so you don't miss out on any future videos. Well, until next time, have a great one.